So let's go to Solver and see if we were to add magic footballs to the model that we had, what would Solver tell us? It should tell us that you should not make any magic footballs. Let's check that out. So go to the second sheet on the template that you have, which is called Magic Footballs. The name of the sheet is Magic Footballs. Open that sheet and you will see that some of the data for the Magic Footballs has already been added. Magic Footballs is now a new column, just like A and C had their own columns. Each variable always has its own column. And similarly, then Magic Footballs column has been introduced or added to our original model, where the amount of time the Magic Footballs will take in the 3 departments is already filled in, 10, 12, and 7. Let's go ahead and calculate how much total time would we be using in cutting and dyeing in making these 3 products. That's already filled in for you. It says it's the sum product of B4, D4 with B5, D5. So essentially, a sum product function, if you're not familiar with it, would do the following for you. If you give it 2 arrays, like we have given it in this case, it will multiply the first component of the first array with the first component of the second array, and then add it to the product of the second component of the 2 arrays, and then add it to the third product of the third component of the 2 arrays. So in our case, then, that would mean that it would calculate 12a plus 6c plus 10m, which is the total amount of time that will be required in cutting and dyeing if we are going to make B4, C4, and D4 of A, C, and M. Now that should be, of course, less than or equal to 20,400. And similarly then, here we are. In sewing, you're going to use the sum product of B4, D4 with B6, D6. That is 9A plus 15C plus 12M total time, which should be less than or equal to 25,200. And then here we go. For the inspection and packaging department, it would be the sum product of B4, D4 into B7, D7. So 6A plus 6C plus 7M should be less than or equal to 12,000. Here is a profit from a magic football. It is 45. And D4, of course, is where Solver is going to tell us how many magic footballs should we be making. The last thing, of course, we need to do is calculate the total profit that we stand to make, which is B4, D4, a sum product of B4, D4 with B9, D9. So 50 into the number of footballs we make of A kind plus 40 into the number of footballs we make of C kind and 45 into the number of footballs we make of the M kind. So that's then our total profit. So the model is very similar to what we did earlier, except that now we have 3 variables instead of the 2 variables that we had earlier. Let's go and fill the information in Solver. So let's call upon Solver. And again, of course, Solver will open this box for you. Let's fill in the information like we did last time. The objective function value is in E9. So click on that. Say you want to maximize it by changing now, instead of 2 cells or 2 decision variables, we have 3 of them, B4 to D4. So click on that and add that information over here. And then add your constraints, which are E5. By the way, you can just drag this at one go and say E5 to E7 is less than or equal to G5 to G7. We are able to do that because this is based on a spreadsheet, and Solver will be able to do a one-to-one correspondence of these 2 arrays. So essentially, it will be able to see that you want E5 to be less than or equal to G5, you want E6 to be less than or equal to G6, and E7 to be less than or equal to G7. So at one go, you can do this, which is advantageous if you had a large number of constraints, let's say.